Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay. All right, let's get started. Thank you very much for coming today. It's my great pleasure to introduce Sriram Krishnamurthy, who's visiting us from Brown University for the next couple of days. So the presentation today is about Flapjacks, which is an event reactive model for programming interactive rich web applications. Let's welcome Sriram.
Thank you. It's good to be amongst old friends, new friends, all sorts of friends. I would like to start by making sure that I'm a little late, thanks to the Microsoft complex, as I discovered. They're putting the complex in the word complex. So I want to make sure that my talk finishes on time, even if I started a bit late. So it wouldn't be a bad idea for us to write a little program to make sure that happens. Okay? So we'll write a little JavaScript application to do this. Many of you, I'm sure, have programmed in JavaScript. For most of you, patience. For those of you who haven't, this will be a quick introduction to how you program these sorts of things. The nice thing about JavaScript is it talks to HTML. You've already got a web page. You can make that web page do things by adding a little bit of scripting to it. So I'm going to write myself a little div, which you can think of as a placeholder, called current time, where I'm going to put the time. I have a function that sets the time by going into the div. You see it says get element by ID current time. So it's finding that spot on the web page, and then into that spot on the web page it's inserting the current time. Okay? And I have to also tell JavaScript that I want to run this. So in my body tag I say here's the thing that I want you to run on load, which is set time. All that make perfect sense? Okay. So if I run this program, why would Ben be extremely unhappy? There's a small problem. Sorry? Yeah, there's a small problem here that this will tell me how much time I have left, and how much time I have left will never decrease. So it's great for me as the speaker, not so good for you as the audience. So in fact, perhaps I want a slightly different program. So let's say I want this kind of look and feel. So it's going to tell me how much time has elapsed, and maybe I have a reset button. Let's think about how to write that program. So it's a little more complicated because the amount of elapsed time is going to keep changing. Okay? It's going to count up from 0 maybe, or count down from some number. All right, what does this program look like? Well, I'm still going to give myself a placeholder on the screen that says current time, and there's a little blank hole over there that I want to fill in. I've got to set some variables. I need a timer ID. I want to keep track of how much time has elapsed. I have to start the timer, and I use a function called setInterval. There's a few different ways you can do this in JavaScript that are all roughly the same. And I want to do something every second, so it maybe tracks how many seconds have elapsed. And then I have to say what I want to actually do every second, which in this case is I want to get the current time incremented by 1 and stick it in the web page. I need to remember to start that timer. But remember, there was also a reset button, so I create myself a button on the screen, and I give it the ID reset, but it doesn't yet have any behavior, so I have to go write the function that gives it behavior. Okay? So everybody here has written a GUI program at some point in their lives, probably many GUI programs. So this style of programming is extremely familiar to you. Okay? Just the syntax is a little different. Now, we should just make sure that we understand what this program is doing, right? I mean, it's just counting up, and when I click reset, it starts from 0 again. The purpose of this program is to fill that hole over there. Now, how do we make sure that it's doing this correctly? Well, it's completely obvious, right? The value for that point comes from that expression over there. The value of that expression comes from elapsed time, whose value is set in the line before it, which happens if I call do every second. Do I actually call do every second? Well, yes, I do over here, but that's inside some other function setInterval, and that function is actually inside start timer, so it all depends on whether start timer is being called, which thankfully it is over here. But in fact, there's more stuff on the screen, right? There's elapsed time equals 0, which may or may not have some impact. Well, it's pretty obvious that's the initialization. But there's also another elapsed time is equal to 0 over here, which of course is called by reset elapsed, which is called by this function over here. Okay? So we spent 30 years getting rid of spaghetti code, and we've done it very successfully. So to reason about what happens in that little spot over there, I have to think about timers, I have to think about initialization, I have to think about overlap, interference, the structure of callbacks, and of course everybody in this room has spotted the bug in this program, right? Good. Okay. So what's happening in these, there is one, and you can ask me later on. So what's happening in these programs is that we have a world out there where sort of time keeps going downward, and we have a program, but the program sort of isn't always running. At some point, something happens in the world, an event loop invokes a callback, that callback runs for a little time, and it returns a value back to the world. And then after some point in time, again, there's another event, the program gets invoked, and so on. But the program, in some sense, isn't running between these invocations. You have these separate threads of execution, and it's the responsibility of the program to figure out how to get values from one thread of execution to the next. And all these event loops return void in JavaScript. And they return void because the event loop is not part of the program, right? The event loop is kind of neutral. It's agnostic to the program. It doesn't want to know anything about the program's computation or its values. It says, I'm just letting you know something happened. Don't tell me anything in return. I don't want to know about it. Okay? So any communication here is the responsibility of the developer. But these are all void returning functions. So immediately you've lost any notion of composition, any notion of typeful programming has been completely eradicated. Furthermore, the only way a void returning function can have any effect on the world is by having side effects, which is why even the simplest program has to have side effects and mutation. Now, Eric Meyer's not in the room, so of course if Eric's here, he'll tell you why that's a bad thing. Okay? Well, he's, oh, hey Eric, okay, good. So, I want you to think that void is a 4-letter word. Okay? It's a bad word because it means even the simplest possible program, I can no longer reason about compositionally, functionally, I can no longer reason about algebraically. I have to think about state, and of course, if you're in a concurrent world, state and concurrency don't exactly interact nicely, but I'm being forced into that structure by the API. Now, you all know that I'm really like a scheme guy at heart. Some of you at least know that. So you all know that this is really just an advertisement for scheme, right? I'm setting you up. So how would I write the same program in PLT scheme, for instance? Well, it's a lot prettier, in my opinion. But unfortunately, it's no better. Because all these things are callbacks. They all end in send. And send is an imperative operation. And the return type of all of these things is void. Okay, well, that's scheme, right? It's like a 25-year-old language, clearly ready to be put to seed. So maybe we should take a look at a nice modern language like, say, Java. Well, I can't fit any Java code on the screen. The screen isn't big enough. But I don't even need to look at the code. I can just look at the API documentation, right? You look at the API documentation, and there's a long list of voids over there. Okay, so that's a structural problem with Java also, but maybe it's just scheme in Java, and maybe we should go to, like, good French programming language, nice stateful programming language like OCaml. Well, the OCaml guys are clever. They don't call it void. They have a different 4-letter word called unit instead. Okay, but that's no better. But it's obvious that, all along, Eric were here, he'd say, you should be looking at Haskell, right? Well, what does Haskell do? Haskell is really clever. Haskell doesn't even use 4 letters. Instead, it uses 2 letters and 2 other characters. But it's 4 characters all the same. Okay? So even Haskell, which rants on and on about functional, structural, recursive, algebraic programming with rich types, can't seem to figure out what to do about basic stuff like GUIs. Even the simplest GUI in Haskell has the same problem. You've introduced the IO monad. This pollutes your program back to square one. So what's happening in these programs is that there's something peculiar about the flow of control of interactive applications. The programs, in some sense, don't run. Okay? They wait for something to happen in the world. And some event, maybe it's a keystroke, or maybe it's a stock tick, or some event happens. That event comes through the model, which then propagates out to all the devices, which may in turn cause further flow of control to happen. But the important thing in all these cases is that the program is not in control. It's the world that's in charge. And all that the program is doing is essentially listening to the sounds of the universe, right? It's waiting for something to happen, waiting to be told to do something, and reacting. And all these APIs that I've shown you, all these return types of void, are simply a symptom of that problem. So it's worth it for us to think about whether, instead of shoehorning our existing languages into these programming frameworks, maybe we should ask, what are the principles of programming in this style in the first place? Okay? Especially since more and more of our programs are of this form. Okay. So I want to think about language support for interactive applications. I've done a bunch of stuff over the past several years on synchronous web programming using continuations and various other things, where we sort of solved this problem there, and we felt pretty good about ourselves until, of course, Ajax came along and ruined everything for us again. So it just means, we get to do more research. That's good. Okay. So let's think for a moment from first principles about what information we're getting from the world. Remember, the program's sitting waiting for the world to tell it things. Well, the world says things like, here's the current position of the mouse. Maybe the mouse moved. It might say, here's some keystrokes that you got, and here's the sequence of keystrokes that you received. Or it might be things like, here's the user location if you're programming cell phones, as we are these days. It might be a sequence of AJAX responses coming back from a server. It might be mode keys. It might be mouse clicks. It might even be, as we've seen, what the current time is. Now, of course, I've employed a rhetorical device here of arranging these things in a very particular way. And as you can see, I talk about current things and sequences of things. Okay? And it's useful to have that dichotomy because current things always have a value, but the value may keep changing. Even as you're looking at it, it might keep changing. The current time, for example. Okay? And sequences of things are discrete. You know, the mouse is clicked once, and that click takes infinitesimally small period of time. Right? I mean, you sort of can't even ask when it happened. But it's discrete. There may be an infinite number of them. You don't know when the first one happens. You don't know if a first one happens. And you don't know when the next one will happen. So these are really two very different kinds of beasts. You've already seen examples of these in the simple program I've shown you. Because over here, that is one of those continuous things. Right? It's always changing. It's always got a value. That's one of those discrete things. You don't know if reset will be clicked. You don't know when it'll be clicked. Okay? Now, this is an idea that I'm borrowing from functional reactive programming, and a lot of what I'm talking about is trying to build and sort of trying to make practical this idea that's been floating around in the programming languages community in a sort of an obscure space in the PL community. It's great work, but we're trying to sort of use it to build lots of real-world applications. Okay? So these things are called, for peculiar reasons, behaviors and event streams. So if you ever see B, a capital B, right? This is my Hungarian coding notation. If you ever see a capital B, it means one of these current things. Think like a timer. And if you ever see a capital E, it means one of these potentially infinite sequences of events. All right? Make sense? So B's and E's. Good.
I guess I don't understand why they don't unify to where the current one is just the first element of an infinite sequence, right?
So there are, in fact, almost duals of each other. Okay, and an implementation will try to exploit that duality. They're not exact duals of each other because duplicate events here matter, whereas duplicates, if I converted this into that, the duplicates would not be visible, right? And again, this doesn't have an initial value that has an initial value. But other than those small algebraic differences, they're almost duals of each other. Good. All right. So the important thing is, of course, these things already exist, right? JavaScript has them, and OCaml has them, and Java has them, and C# has them. But the important thing is when something changes, so that is either the current value changes or a new event appears, the important thing is we want all dependencies to update automatically. That is, we want to make keeping things synchronized, keeping things consistent, the problem of the language rather than the problem of the programmer. Right? So I'm going to show you two languages where this happens. One language is something called Father Time, and I want you to think of it as scheme that behaves funny. All right? So here is Father Time, and it's running inside Dr. Scheme, which is a programming environment. And standard scheme expressions just kind of work. Okay? They look exactly like they do in Scheme. You write a functional expression in Scheme, and it has exactly the same value as it should in Scheme. And in fact, that's by definition. You can even ask for something like the current time, and it comes back with a constant, right? The current seconds is some number that is the current seconds. Of course, even as it appears on the screen, it's already out of date, but that's your problem. If instead I ask for something called seconds in Father Time, I get something that's rather different. Okay? And this is a honest-to-goodness value, but it's a value whose value keeps changing. In fact, I can do things with seconds, right? Or I could even do something like an expression like this. And as you can see, I can nest as far as I want to. It's the language's responsibility to keep the overall expression up to date, not the programmer's. Okay? So I'm writing what looks like just a functional dependency, but the value keeps updating because that's the language's responsibility. So there are several important ideas in Father Time that I'm not really planning to talk about in this talk. One is this incremental read-eval print loop, right? Just like you have in a language like Scheme or ML, actually works even with these values. We have a systematic way of taking OO libraries in particular GUI libraries, and converting them into these reactive interfaces. So for example, we took like a 100,000 line GUI library, and with about 400 lines of code, we get a reactive interface, so you can program it functionally. And we have lots of optimizations and a very nice implementation strategy that reuses existing call-by-value languages. Okay? So there's a bunch of papers and stuff on this. What I want to do is, instead of talk about these ideas, I want to tell you about a slightly different language called Flapjacks, which is essentially the same thing, though. It's JavaScript that behaves funny. Okay? So let's see that timer program we talked about at the beginning of the talk written in Flapjacks. Here's what it looks like. So just like I have seconds in father time, I have something called now b, which is the current time. It's a b, which means it's one of these things that always has a value. So graphically, you can think of it as being something like this, right? It's always got a value, but the value keeps changing. I can also say, take some element in the web page, any DOM element, and turn it into an event stream. So take the reset DOM element, take all of its clicks, and turn it into an event stream. So graphically, it looks like this. Nothing happens, bing, a click happens. Nothing happens for a while, bing, another click happens. Okay? Now what I'm trying to do is I'm trying to get from here to over here. That's the answer that I'm trying to compute, right? That's the elapsed time since the last reset. How do I get there? Well, I want to know what time each of those clicks happened at. That is, I want to take a snapshot of the value of now b whenever a click happens. Well, so I take that previous expression and I say snapshot the value of now b. If I don't snapshot it, remember, it's always going to be kept up to date automatically. So I have to say, right now, halt computation for this instant, tell me what its value is, and remember that value. Okay? So if you're a functional programmer, that's a kind of map, right? I'm just mapping over this event stream. But I really want to turn it into this, right? I want to turn it into a behavior. I want to turn it into something that remembers its last value. Well, so starts with is an operation that says, give me an initial value, which is some starting time. Okay? In this case, maybe 12 was the starting time. And hold on to the value you asked whether these could be interconverted. Starts with is exactly one of those interconverters. Okay? Starts with says, hold on to this value till it changes, then hold on to that value till it changes, then hold on to that value till it changes, and so on. Okay? Now, this final expression is just the difference between those two expressions. It's just algebra. And I can send this to some show time. So the point is, show time can just be some arbitrary JavaScript function. It doesn't need to be in any of this reactive stuff. It's just getting a value, and whenever it gets a value, it gets pushed a new value, it just updates it on the screen. Okay? So every time now b changes, it pushes a value to all the dependent expressions, which also update, which pushes a value to all of its dependent expressions, which also update. And if one of those happens to be on the screen, you're just going to see the change on the screen automatically. Okay? Yes?
So snapshot takes the event stream and it tells you when to evaluate its argument. The click had no information other than the fact that the click occurred.
Exactly.
If it was a key click with
It actually does have a little more information. So it does actually tell you which key got clicked. Whatever JavaScript is going to give you, whatever event object JavaScript is going to give you, is actually available. But I'm choosing to ignore it.
You could use that as a separate argument to snapshot?
I could use that as a separate argument snapshot, yes.
So there's some discretization going on.
Yeah.
And it's not clear how you're doing it. So obviously it looks like you're creating a new value every second, but where is that captured essentially? Is it every millisecond? Is it every?
Oh, so that's a function. So the evaluation model is completely push driven. So now b in this case happens to be defined over a millisecond timer, but it's whenever the timer signals a change, that's my unit of discretization. Okay, so I'm dependent on whatever discretization is already in the system.
So if you've got multiple things generating things with different units, then
yes, good. So in fact, there's an important property in the evaluation model which I'm not going to talk about in this talk, but I could explain later, which is something that we call glitch freedom, which says you never see things that are inconsistent. You never get a value that's not consistent with the expressions you have in your program. Okay? So in this case, for example, if you have two different timers, they actually come from the same timer. Right? Essentially, you have some timer that's pushing in two different directions and coming back together. You're guaranteed that the value you get there is, in fact, the functional value you get from these two different expressions. Okay? And that's an important semantic guarantee. It's one of the important parts of what we did in Father Time was to provide that semantic guarantee that you really get what your expressions say. Okay? And a naive implementation will not give you that. So there's a bunch of things I could say there, but yeah, I'm not going to say that in this talk. Okay? So just to summarize this expression, this is the expression. I take now B, I take this event stream, I convert it into a behavior, say what it starts with, and the thing I like about an expression like this is I've turned time, which is an input, well that's fine, that's just an input, but you don't think normally of buttons as being inputs. You think of them as actors or actions, you don't think of them as values, but I've turned the button into a value. So this whole expression gives me a value for the button. And I can just think of it as a value that I'm computing with, and I pass it to a function, so I'm back to writing expressions that look like functions of inputs, and independent of the fact that these happen to be highly reactive and changing and so on. Okay? So that's an important detail about the programming style that this language engenders. All right. So we've built a bunch of applications with this. We've had several people build third-party applications. We built several working applications that people actually use. So if something goes wrong, my reputation's at stake. Yes?
Maybe you'll get to this later, but
yeah.
I didn't see how the event stream model solves the problem of those dependencies that you alluded to in the first part of the talk. You had these complex dependencies among different parts of the...
Well, so this is the whole program, essentially. I mean, there's a little bit missing, but this is essentially the whole program. Right? So the dependency between the button and the value of the button is expressed in this expression. So I should try to answer your question right here with this screen. Okay? So the point is, there is a timer hidden underneath here. Okay? But I'm giving you a completely different way of writing that program. I'm not telling you how to massage that program a little bit. I'm giving you a totally different model for writing that program, which is to think of all the expressions as being pure expressions, writing functional compositions of those expressions. So where does that break down? You remember the first slide I showed you was just a really dumb program in JavaScript that put the value on the screen. And I said, what's wrong with this? And as you rightly point out, it only presents the value once. Okay? So what I'm asking you to do is think in terms of the program running once, right? But if you now change some of the sub-expressions to actually be things that run many times, it becomes the language's problem to rerun the program for you many times. That's the model I'm presenting here. Okay?
Sounds like the answer to this question is complexity is in the language.
A lot of complexity gets buried in the language. So things like the optimizations and so on do become relevant. Yeah. Yes?
I'm just thinking about, so in some ways it's a familiar model in the sense that when we have an Excel spreadsheet,
Absolutely. Absolutely.
It's propagated, right?
Exactly.
I don't know if there's a way to update a cell every second. I'm sure there probably is.
There must be. I'm sure there's some VB thing you can do that the Excel rewriter then picks up on.
Right.
But I'm also giving you sort of all the benefits of higher order functional programming. But yes, it's spreadsheets, and as you'll see, it's spreadsheets extended up to mashups and so forth.
Right.
Okay. Yes.
So you said that the evaluation model is entirely push-based.
Yeah.
Does that mean that, say, I don't know, go back to the same example. If you cover your window with another one,
Yeah.
there's really no need to recompute anything underneath that window. You would rather go to pool model in that case. It's only
yes.
when the window sort of appears again that you want to.
There's a complex argument in both directions. You're right. Okay. So yes. You could view it, that's a perfectly reasonable thing. You could, if you wanted to, add another event over here that said, am I visible? And visibility would be another event that triggers computation, and then you wouldn't be computing if it weren't visible.
You're saying that you can actually express everything that is compelling pretty much with the push model?
With the push model, and the push model has the advantage that I don't have to pick a polling frequency.
No, I'm all for the push model.
Yes. Good. Okay, so there are several applications, but what I want to do is, you're programmers, well, you're researchers, but you might even write programs. Actually, you guys do write programs, right? You have to write your own code, so that's the nice thing about talking at a lab. I want to give you a feel for what it's like to program in this language. I don't want to talk about the theory of it. There's papers for that. I want to give you a feel for writing actual programs, writing abstractions. Okay? So let's start with a very simple abstraction that I've pulled out. So I'm not going to show you the whole applications. I'm just going to show you little snippets. And this is an example that shows up repeatedly in the systems that we build. But since you haven't used our systems, here's one that you have, well, maybe not in this room, but you've heard of something called Google. It's a company out in California. And they build this thing called Google Mail. Okay? Wherever I say Google, you should hear Windows Live or Buzz or what's it called now? Bing, right? Okay. So imagine there's Bing Mail. Okay? All right. So in your mail program that's web-based, what you'd really like is an autosave buffer. So as you keep typing here, periodically, the content gets saved onto the server, so if your browser dies, you don't lose your content. Okay? Good. So I want to build an abstraction like this because it turns out autosave buffers are useful for everything. They're useful over here. They are useful in conference reviews. You don't want to lose those either. They're useful in job searches. They're useful in various wikis and so on. Okay? So let's build this autosave abstraction. And by the way, notice it also does things like tells you when it was saved and so on. You might also have some styling that says, do something to the background when it's in an unsaved state, etc. Okay, so let's write this widget. So I want to create a widget. I want to put it in a library so I can reuse it in lots of applications. So let's say it's called MakeSaveBox. So obviously, it needs to create some kind of text area that I can type into. Okay, so we'll call that doc. And maybe every 60 seconds, it's going to set off some timer to go off and save this thing, and it returns document. Okay, perfectly sensible. There's one shortcoming with this, right? What if you want to save on a different frequency? Well, you don't want to save 60 seconds. Maybe you want to make that a parameter. So we'll make that a parameter, okay, of t. But is that the only reason why you might want to autosave? Because the timer elapsed? Are there other reasons you might want to autosave?
What if somebody clicks a button that says save draft?
Save now. Bingo. Okay? So almost as if you were planted. Okay? So somebody clicks save now, and you want to save then also. All right? So maybe we should add a second parameter that takes the button into account as well. Okay? So there's our thing, right? It's either every t seconds or when button clicks. But I'm actually using English on purpose because it's not entirely clear what I want this to be, right? There's other possible definitions. It's like maybe when the button clicks, or if t seconds had elapsed since the button had clicked. Or maybe it's like when t seconds and button clicks, or it's after every keystroke. Or maybe I want to do something if nothing changes. Or maybe I don't want to do something if nothing changes. There's, so clearly it's obvious that I need to add about 4 or 5 more parameters, right? And that's when you go read your Perlis epigrams, right? And Perlis says if you have a procedure with 10 parameters, you probably miss some. So how can we present a better abstraction? Well, to me, there's actually an obvious abstraction here. It's an event stream. Okay? You want to pass in an event stream and say you save every time the event stream fires. And I can then pass in different kinds of event streams. I can pass in a timer that says, fire every 60 seconds. I could pass in something that says every time the box is clicked. Or I could merge those two streams, right, to say every time the box is clicked or the timer fires, or more complex compositions. So this is where now having a good, rich programming language, a little richer than Excel perhaps, a rich programming language and the ability to write combinators and the ability to merge these event streams becomes really useful. Because I've now achieved something that's a very valuable separation in computer science. It's the separation between mechanism, which goes inside, and policy, which comes from the outside. And all these are representations of policies. Yes?
So when you merge two streams,
yes.
What are the elements that you get? It seems like there's a type issue.
Oh yeah, there is. Oh yeah,
Okay.
yeah. It's JavaScript, man. Yeah. Until about 12:25 tomorrow, I won't have to worry about this question. So yeah, no, there is, and in this particular case, so the question is, what do you actually need out of this event stream? If all you're treating it as a policy, you don't actually care about the content of it at all. Okay, so that's why I can ignore that question here. Yeah. In fact, so just to give you a quick preview of what I'm talking tomorrow about a type system for JavaScript, and we can type all of these programs. So here, for example, the types would be very simple because they would say, all I expect is that it's an event stream. Okay? And if the mechanism tried to inspect the values of the event stream, obviously it would be in trouble. Right? So this particular one, it's just an event stream. So I get this nice policy mechanism separation and a useful way of thinking about how to structure this program. And in fact, a useful way of thinking about how to structure all of these sorts of abstractions, which is use event streams to represent policies, don't do too much in the mechanism itself. Now, of course, what I've done is I've shown you how to fire events, but I haven't told you anything about how to save something on a server. Well, so, in web programming, it's standard to think about the server as being the place where persistence is done, reference monitoring, access control, and so on. And you just send requests and get responses, right? And you have primitives in JavaScript for doing this. So we have a primitive in Flapjacks called getWebServiceObjectE. Terribly unwieldy name, but I'll abbreviate it in the talk. But the important thing is getWebServiceObjectE takes a stream of requests and returns a stream of responses. So I want you to think of, earlier I said I want you to think of a function as being written once, but running every time, as many times as necessary. This is the same sort of thing. I want you to think of the server as something you contact once and get one response from, but then it's the language's job to lift that to being something that takes a stream of requests and returns a stream of responses. Okay? So once I have get web service object E, it's pretty easy that all I do is I have these requests, and when E was the merge of those two streams, well, it's the argument, which was coming in maybe as a merge. I snapshot the value of doc. I have to snapshot it because I want that instantaneous value. And I have a make request function that constructs some JavaScript object with descriptors, URLs, and all the usual stuff that the server is expecting to hear. And I pass that stream to get web service object E, and I get back a stream of responses. Okay? So that is how I do the saving, but I might want to do more. I might want to also style it. So for example, we like to draw a little back, we'd like to change the border color of the box between saves and between the sending of a save and the acknowledgement of a save. Yeah, Andy.
This feels like it has the flavor of star Lisp and for the connection machine, in the sense that you have these values that are single variables that have like a huge number of values inside. Like what happens if you wanted to do an if statement on the return value of one of these things? Do you just say if saved E equals something, or do you have to do $V of saved E?
How about we look at the next slide? So perfect setup, almost perfect setup. I'm not going to do quite an if, but you'll see how exactly the sort of thing you're talking about might get addressed. Okay? So after the next slide, we'll get back to your question. So for example, I want to do styling, right? I want to say, depending on the state of the box, I want to change the way the box appears. So I have saved E that I have right now. I also pull out all the changes. Right? So every time this doc thing changes, I have an event stream for that. I now transform changes with the constant unsaved. I transform the saved responses with the constant saved, and I merge those two. So now I get an event stream that might look like unsaved, 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 saved, unsaved, 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 saved, unsaved, unsaved, saved. Okay? So every keystroke, basically, this one keeps getting to unsaved. Every time the server responds, it comes back and says saved. Well, I turn that into a behavior. The empty buffer is, let's consider it saved. Okay? So I transform it to behavior. I can now use this behavior to style the border color, or style the content, or style whatever I want. Okay? So I don't, yeah.
So this is all well if the server behaves perfectly. What if the server is unreachable, or you drop your connection, or it gives you a response that you didn't?
I actually deleted about 7 slides last night about how we handle fault tolerance. So we have a set of primitives for doing fault tolerance for Ajax applications. Essentially, the idea is you can use continuations and do replay techniques, right? And you can integrate that with flapjacks. And I felt the talk was going too long, so I deleted all of that. So, but yes, that's an extremely legit. And in particular, if we're going to program on a distributed setting, we absolutely have to think about that. Yeah. I'll get to your question in a moment. Andy, I don't know how much this helps with your question. I want you to think of these as point-wise operators, but sometimes you might want to collapse them. So you might want to have an accumulator, you might want to run a filter, any of those things, right? But you never say if saved E. You do things point-wise.
It's just
Yeah,
it's a Cindy.
yeah, you never get to be able to ask. Well, Starlab had the ability to sort of collapse things into single values that you could ask.
Right. So you could do things like maps or accumulators. You got to be careful about defining what it means to collapse, right? Because these are infinite streams. So.
Dimensions time.
Yeah. Yes.
So if I understand the semantics of this program correctly, then when the border changes to indicate that it's been saved, it's not necessarily the text that you see on the screen that has been saved, because you're actually looking at an outdated response.
That's exactly right.
If you type fast enough.
That's exactly right. And in fact, you could take this program and make it more complicated. No, because no, that's right. Yeah.
It basically means saved recently.
That's correct. Saved in this case means saved recently, and I would have to define something a little more complicated to say saved and not changed since then. Yeah. Okay. Good. Okay. So let's now try to write. It's a web talk, so I've got to say something about pipes and tubes somewhere in there. So let's say that what I want to do is I want to set up a little thing where you can type in text, and the text you type is a search string that's sent to Flickr, and it pulls out all the images that are available against that search string and sends it back, which you now display on the page. Okay? So again, I'm going to assume that I have some JavaScript functions that take a string and turn it into a request and take the response and turn it into a list of URLs. So this is marshalling and unmarshalling, right? This is just parsing stuff. So I set up a box, search box, pull out the event stream of queries that text that gets typed into it. I then map it to turn it into a set of requests. As you can guess, I'm going to send that request off with get web service object E. I'm then going to map the responses with this other pure function or some JavaScript function. And if I start with the empty list, then what it's saying is the empty box corresponds to the empty list of responses. As I keep typing, I get new lists of responses. And finally, I can put that into my web page by just inserting it into some development called thumbs. Okay? So again, I'm doing functional programming, but what it's telling me is that every time search changes, query is going to update. Every time that updates, request E is going to update. Whenever that updates, response B is going to update. And every time that updates, the content on the screen is going to update. Okay? So all I'm doing is showing you the same primitives I've shown you before to construct a fairly different application. But there's something really annoying about this application. What's really annoying is that every single keystroke I type, this thing's going to go off and send something off to the web, right? And that's bad. That's really annoying. I mean, you know, web's not really free, right? So in fact, the programs that we write look just a little different. We use something called COM-E. And COM-E is a combinator that says, don't bother about any events during this period, during this duration. So in this case, wait for a second. So let this person keep typing and wait for a second. And when there's a second's pause, then do something. Okay? So drop events till then and filter out the events. And this is a really useful primitive for all sorts of user interactions because you want to avoid things happening too quickly on screen. So COM-E shows up all over the place. Okay? And so one of the things I could do is I could actually use something like COM-E to clean up some of the behavior I showed in the previous slide, for instance. Okay? All right. Another thing you can do is take user interface content and behavioral content and package them up nicely. Now, this was supposed to be what object-oriented programming did, but sort of tends to do pretty poorly, and the whole callback style reveals where that weakness is, where that falls apart, right? Because you have all these weird control flows between components that aren't properly localized. So here is Resume. This is a job search manager that several computer science departments use, and these aren't real candidates, don't worry. And over there, you see that there's a little filter applicants box. And if I click on it, I get a box that looks like this. So there's all sorts of criteria that you can filter applicants using. So I want to show you a little bit about how this component of Resume is written. So I have a function that's, say, called pick gender. It should be sex, but we're Americans. We don't use such words. Okay? So I have a user interface component, which in this case is a selection box that has two values, either male or female. And I'm going to return a package of two things. A DOM component, which is the UI, and a predicate, which is pretty obviously take the value out of the UI. So here, lexical scope does the right thing, right? Take the current value of this, compare it against person.gender for whoever the person is, and give me back a Boolean. Okay? So that's a filter. I can also have a different filter that maybe is a score, and I have a text box, and I can do various styling for the text box to make sure that that's the way I want it to be, and I can have a checker for that. And now these are functions that I can use directly, right? So I can take one of these things and separately pull out the UI component and put it on the screen, and the DOM component and put it on screen, and the pred component, use it as a filter. If, for example, I apply this function using filter to a list of applicants, every time somebody types something different over there, automatically my list of applicants filters. So anybody here who's used iTunes knows that you have a little box up in iTunes, and as you keep typing text, the content down here keeps changing automatically. You don't have to press return and so on. And that's exactly the behavior you get for free by using this. But in fact, you also want to combine filters. So for example, you have a list of filters, and there's a function that says, tell me which filter you want. So I create an option that says what the filter options are, a selection box for that. And subfilter is just take this selection, look up the corresponding filter, and that gives me back the specific selected subfilter. And what am I going to return? Again, a filter. So the DOM is just a span that says, here's the filter you selected, and here is the DOM for that filter. So if you select this kind of filter, you get one kind of search box. You select a different filter, you get a different kind of search box. And the predicate is just the subfilter's predicate. Then we have combinators over these, the usual AND and OR combinators. And that's how we compose that big filter box that you saw. So it truly is, this is literally the kind of code that's running there. There's no tricks, there's no sort of weird imperativity underneath, right? This is the code that's running, and you can compose these to build bigger and bigger filters. Finally, let me show you a sort of mashup-like example. So in this case, I'm going to take Twitter and Google Maps. So Twitter is, Twitter has people say random stuff on the web, and they put out these things called tweets. And there's a public Twitter stream that you can get from Twitter of all the tweets that people are saying in the world. Okay? Don't ask. Yeah. And I might want to mash this up with Google Maps or Live Maps or something to show where all these things are being said, right? Just to waste even more time. So for example, I went last night and I started the program, and the third thing I got was there's somebody in Boston who's clearly kind of hungry, and then a few tweets later somebody is wishing somebody else good morning. So as these tweets keep appearing, I want them to keep displaying them on the screen, and maybe when I click on the button I want to get the text. I'm not going to show you all the code here, but I want you to understand that there's an interesting principle. The principle is that this is the name of a function from the Google Maps API. Okay? And you can see my callback principle being illustrated nicely. So you give it a string that says, Providence, Rhode Island, Bangalore, India, whatever. You give it a string, and it comes back and gives you the geocoded location for that string, if it's able to succeed. Okay? So there's a function of this form. What we do is we take functions like this and systematically transform them into functions of this sort. Okay? We make them typeful, basically. Now, I'm not going to tell you how we do it, and it's actually a little challenging. So if you're really following along in the talk, you might want to think about how you might be able to write such a transformer. There's one piece you're actually slightly missing, and you should ask me about it if you're interested. But the point is, this is something that we can do systematically, and we do it one time. So now we have a way of getting event stream. I have a way of getting a geocoder that takes an event stream of locations and gives me back an event stream of geocodes. So I guess point should have been geocode. So I have that function. I'm actually going to give you a slightly different function. It's also going to carry some additional data if I need to. So it takes some additional data and gives me back that additional data, just passes it through polymorphically. So I can overlay additional information beyond just the location, such as the tweet. Okay? And similarly, I'm going to get a get Twitter pub tweet. So take Twitter's API and turn it into an event stream. And also a map overlay, which is take an event stream and overlay it on the map. Okay? So now I've got event streams everywhere. So I get the tweets. I map this function over here that basically takes the tweet, passes it to Google, and gets back the geocode for that tweet. Right? So this is just the transformation from the Twitter information to the Google information. And now I have to filter out all the ones that came back with false, because sometimes you give it the name of a string and it says, I don't know where this place is, because Twitter's not giving it quite the right information. You filter those out, and you overlay it on the map. So this is really you want to think of it as classic Unix-style shell programming, right? Except I can do this also for mashups. All right? So what I'm trying to do is give you a feel for what it's like to be a programmer in this language. You think functionally, but you get all the benefits of sort of object-oriented programming and subtyping and so on that work in just the right way. And most of all, you get to write what are essentially functional specifications that say, here's the one-time behavior of what I want, and if something changes, make the language do it for me. So I'm going to leave you with one more abstraction, and this one I'm not going to show you any code at all, because I really want you to think of it as a challenge. Okay? So the DOM, as I told you, provides events. It tells you about mouse ups and clicks and so on. And every programming language API, right? C# comes with a bunch of things. Visual Basic comes with a bunch of things. But it doesn't give you complex events, right? It has a bunch of primitive events, and that's all you get. So, for example, it doesn't give you drag and drop as an event. But that's a reasonable thing to think about. In fact, it's a reasonable thing to think about because you're used in all sorts of contexts when you're building GUIs. For instance, if I drag over there and drop, I mean I want to move the buffer or move the window. If I drag over there and drop, then what I'm saying is I want to resize something. Or if I drag over there and drop, then what I'm really saying is I want to select something. So if you're building a GUI that has these kinds of operations, it's really useful to be able to think of drag and drop as a primitive, and then you can ask contextual questions about where you were dragging and where you were dropping to figure out how to interpret this, right? And you might even want to do different interpretations depending upon other circumstances. So the challenge for you, if you have a programming language, a favorite language, is how would you encapsulate this as a event of some sort, whatever the event encapsulation of your language is. And if you're curious about how we do it in Flapjacks, we have a section on this in our paper, and we show how to get this as a honest-to-goodness abstraction. So you can say, here's a drag-and-drop event stream. It's actually, so speaking of your question about types, it's an alternation of drag events and drop events, but it's still an event stream. Okay? And we can actually then write a whole bunch of functions. Think of it as like you get this visitor kind of abstraction, right? You get a type, and then you can write functions against that type. Here you get an event stream, and you can write lots of different functions that plug into that event stream. So it's giving you back that functional abstraction capability. All right? Good. So this is actually a little complex, which is the real reason I'm not showing you the code. I'd love to, but it'll take about 3 pages, and that's too much code. All right. So I want to start wrapping up what I've said in this talk. One of the nice things that's happening is other people are beginning to realize that there's value of thinking about the internet as communications of event streams. Opera actually published this API. It's not a very good API, so it hasn't really caught on, but I think over time, people who build web servers are sooner or later going to start wanting to publish better APIs than they do. And in a way, they already, if you think about Atom feeds and RSS feeds and so on, they're getting at this idea. They just haven't sort of sat down and formalized exactly what they mean. Okay? So the world already thinks this way. In fact, if you think about these behaviors, if you've programmed in JavaScript, you already have a behavior even if you don't program in Flapjacks. It's called the DOM. Because if you think about the DOM, any change I make to the DOM automatically gets propagated to the page. I don't have to make a change and then notify somebody to then go off and do the update. Anything I do to the DOM is automatically propagated out without any additional effort. Okay? So you can think of Flapjacks as saying, well, why is it that only the DOM is this privileged data structure that gets this capability? Why not whole bunches of layers that get this capability, pushing all the way through and ending at the DOM? That's one way to think about what we're doing, is generalizing that principle. Yes?
So, one characterization of what you're doing is you're taking time as a dimension and you're making it explicit, basically. And things are changing, through these events or whatever. And your abstraction is exposing that. So every slice of time, you're doing things essentially,
yeah.
And you compose. It gives you this compositionality. What it doesn't give you is the simplicity of reasoning about just one state change. I mean, in other words, you lose the ability to think about a single. I go from this to that. Mm-hmm. I respond to a single event. Mm-hmm. I have to think about the fact that now I have a stream of these things, and everything I do has to deal with a stream. So I think it's great. I mean, I'm really excited about the idea that you can get this abstraction. I think one of the barriers to acceptance is going to be this kind of change of thinking, not just about single, it's just like sequential programming versus functional.
I think you're absolutely
functional
right.
Functional programming, you always think about maps and higher order functions, right? Most programmers think about, I make this change and it's a single...
I change this one variable.
Yeah,
yes,
yeah.
yes.
So I think it's a very similar kind of...
I think you're right. In fact, what happens is I've actually gone through this exercise several times of trying to write a program in a completely standard JavaScript style and then slowly transform it into Flapjacks. So one of the weird things about Flapjacks is we offer it as both a sort of language that does some of this stuff for you automatically, but also as a library. So you can just program in JavaScript with this as an extra library, okay? What do they call them? Kits, I guess. So there's some term the JavaScript programmers like to use. So anyway, so I've gone through that experience. And it is actually not completely trivial, even for me with my experience, to do that, because what it's doing is it's forcing me to say, it was really easy to write this one step, okay? But then, as you say, but the problem is then I don't know what my sort of long-term behavior is. And in fact, I get horribly confused because it doesn't seem to be exactly what I expected it to be. So in some sense, what I'm doing, and we had the same experience with continuation-based web programming, is we said, we're going to put a slightly greater burden on the programmer, but what it does is it reduces the burden on all sorts of downstream tools. So verification tools, program analysis. So we built a model checker, we built program analyses and so on for our web application framework. And it became a lot easier because we made the programmer do this little bit of extra effort, right? Of not just sort of sticking everything in a string and saying, okay, I'm done. And then when I have to restart, I'll figure out how to pull all of my data back. And maybe it's not there. Maybe I don't know what's really going on, right? So it's the same way. reasoning about this, say with a theorem prover, is much easier because you can do this sort of functional reasoning, but it does push the burden onto the programmer, and that's not always a popular thing. Yeah. Yes.
So coming back to the analogy with the DOM that you made.
Yeah.
One of the nice things about the DOM is that it's one data structure that is persistent across multiple invocations of JavaScript routines, so that even if one of them fails, you still can go back to the DOM and do something acceptable. Whereas what you're saying is now your entire code has this sort of semi-persistent property. So as a programmer, I would think it's the burden of ensuring that nothing fails is much higher in this case. Do you agree, disagree?
Well, I'm not sure that that's necessarily true, because if I have some behavior attached to a timer, say, okay, I've got some timer that's running over there, and let's just say that I happen to have an error in my function that's attached to the timer. The next time the timer fires, that function is going to be called again. Okay, so I might have some piece of code here that has errored out. In fact, I would argue part of the problem with JavaScript is that weird things happen, right? Little pieces of code error out, and other pieces of code just continue happily running, right? Even though the world may be in an inconsistent state. So I think we're at least in a better position to say this is running against an inconsistent state, because there's some expectation of what the state was supposed to be. It's this property I said that the expression is, the value is always, can be computed simply from the functional expressions. So at least we have a chance of saying, the world is running, but it's an inconsistent state, and you might want to be aware that the output you're getting doesn't quite make sense. In contrast to traditional JavaScript, where you run your program and you've got this web page and things sort of run, and then you click on a button and nothing happens, and then you go to the error console. I actually like asking people, do you know where the JavaScript error console is? It's shocking how many even programmers have no idea there is an error console, right? And you open it up and it turns out there's like 20,000 like little yellow triangles and one red thing saying there was an error. And it's some weird property and undefined. And the other thing is JavaScript's also part of this sort of HTML culture of try not to make things error out, right? It's actually hard to get JavaScript to give you an error. Like, I mean, you can say undefined dot some method name and it says, okay, now I really can't just make up nonsense. But short of that, it's pretty hard to get it to actually stop and say, sorry, something went wrong. So I'd argue that that is not such a good thing in the first place. And having some sense of what the state of the program was supposed to be might actually save you a little bit there.
Well, I agree if you are writing all the code on the page. That's
I see.
Importing other code and stuff like that, you want to make sure one of them doesn't end up breaking your page or breaking the...
Well, but in that case, you would just have had a whole bunch of separate event streams, right? And one of them is broken. As long as you are, you're in one of these mashup cases where you have isolation, you're trying to achieve isolation. So you have all these different mashups that are presumably presenting event streams, okay? You're creating like an iGoogle kind of page or something like that. Then each of these things is presenting towards event streams, so the breakage of one thing completely does not affect another. And in fact, I would be able to tell you that. I'd be able to tell you that this value is this is the cone of influence, right? Or this is the cone of contribution for a value, right? It's all of these expressions. So if the error is outside this cone, you can be sure that your value would not have changed whether that thing ran or not. That's harder to achieve in JavaScript because you have to do a program analysis through a DOM model to figure out whether that's true or not. So I'd actually argue that you're making a good case for this style of programming. But that's a rhetorical point. Yes?
Perhaps, but it still seems like it's possible to end up with too much reactivity.
Yeah.
Right? So in a sense, I mean, so the worst case is always, touching the DOM. Your code of influence is going to be touching the DOM, and the DOM is just this giant structure and everybody's touching. So unless you iframe everything away, you're basically sort of back to square one. And
that's right.
Another thing is that in terms of inclusion and mashups, there's also a possibility of, denial of service or some form of thing like that, where you have this superfluous reactivity or something that you didn't really quite expect to be reactive that just suddenly kind of flares up on you.
That's right. I will not even begin to pretend that Flapjacks is giving you a handle on getting good web isolation. Okay? All it's doing is in the case where something is sort of half broken, it can tell you whether or not that brokenness affected you. Okay? But the isolation problem is not, this is not solving that problem.
It's not the isolation problem though. Maybe the evaluation model might change. So in this circumstances, you observe that the previous invocation errored out.
Yeah. That's right. That's right. That's right.
possible.
So in fact, you asked the question about talking to servers that might be flaky, and that's sort of what happens. We have this retry-based model that's essentially, think of it as a transactional model, right? So we want to know which invocation point were we at, which time through the invocation point, and which retry were we on, and that way the server and the client are able to tell whether our state is synchronized or not. Okay? So there's a triple that basically identifies a unique point in the computation, and each of those transactions can then be retried precisely because it says, I haven't heard back, here's a timeout policy, go do the retry of the computation. Yeah. Okay, a few more things I want to say. So, I keep sort of alluding to functional programming, and, is this purely functional? Well, it's a weird thing because it's functional programming over imperative values. Right? And normally that makes no sense, except in our case we're saying it's functional programming over imperative values, but because the changes are automatically updated, you don't notice the fact that the values are imperative. But in fact, you can actually introduce imperativity into the program, and I've been doing it from slide 1, because that's what snapshot does. Right? So consistency is a primitive, but snapshot says stop evaluation of this little sub-expression. I want to know what it was then, as opposed to what it is now. So one question we can ask is, should we be snapshotting by default? Because that's what traditional programming languages do, right? In fact, I would call a variable as sort of a failed behavior, right? It's an aspiring behavior that never made it all the way, right? Behaviors are just variables that don't have this problem. And we've looked at lots of our code, and we find that the number of snapshots we use is roughly like 1 to 5 per 1,000 lines of code. And this is actually old numbers. There's many more applications now, and it seems to be consistent. So you could argue that maybe having snapshot as the explicit operation rather than update be the explicit operation. The bug, by the way, anyone catch the bug in the initial slide thing? What happens is you propagate, when you click reset, it propagates to the variable, but it doesn't propagate to the screen. So when you click reset, nothing happens on the screen till the next time the clock goes off, and then it starts at 1 rather than starting at 0. Precisely because in some places you knew to take that value and send it to the screen. In other places you forgot to do it. Okay? And I must admit, by the way, that it sounds like a setup, but actually I made that bug in my program myself and then said, aha, good. Well, so maybe it was subconscious. I don't know. So I'll end with a sort of purely rhetorical slide. So this is Eric Meyer runs the software radio something something, and he went and interviewed Simon Peyton Jones, right? So here's Simon, right? So Simon, so I can't do this sort of Simon accent, so I'll just do this my way. So anyway, so Simon draws this graph, right? And he says, look, there are languages, all right? And they're on a spectrum from useless to useful, okay? These are Simon's words, not mine, okay? Simon, if you're there, hi. And there's another spectrum here from sort of unsafe to safe. Okay? And so he uses the phrase, this is literally his quote, unsafe means any effects anywhere, and safe means very limited effects or maybe even no effects. Okay, so he says, I'm going to start plotting languages on this graph now, right? So, C and C#, Java, all of those things start out over there. I suppose that looks a little like Mickey Mouse, but that's coincidental, I guess. And now it's Simon saying this, right? Haskell is over here. Right? So in its purest form, right, Haskell is like all the way at the bottom over here. It is it's sort of at this corner, right? It's extremely safe, but you don't even know if it's running, right? Maybe you put your hand on the computer to see if it gets warm, but even that may not be, nothing happens. Okay, but his point is that, Haskell has been moving upward. That is, it's been adding effects in a very principled way. I actually think monads are kind of a losing monads are, I've got lots of issues with monads. But anyway, the point is the Haskell community has been moving upward here. But so have those languages. They've been moving sort of to the right, right? Which is, separation logic or ownership types or any of these things are basically ways of saying completely unfettered effects everywhere are not such a good thing. Transactions are also, transactional memory is kind of that sort of thing too. It's saying maybe if we can think of things in a little less effectful manner and we can give the language a little more ability to reason, that would be a good thing. And so natural question now is, where does flapjacks fit on this slide? Well, so I'm going to say I sort of reject this diagram a little bit because I think flapjacks, I told you it's a rhetorical slide, I think it belongs somewhere around here, okay? Because it's obviously a useful language. People have built applications with it, even we've built applications with it, but it's very much along the sort of right end of this. It would seem to me that there's some sort of principal axis over here, right? And everything has to be sort of in this lower left triangle. And yet I claim sort of flapjacks is a little bit outside this triangle. And I think it's because I don't entirely buy this phrase, very limited effects. I mean, it's not even clear to me why effects are a bad thing, right? I mean, effects are computers actually doing work and making themselves useful to us. So I don't think that should be considered a totally bad thing. So it's a question of what this phrase really means. Is it very limited effects? Or should it be maybe limited observable effects? Well, that's okay too, right? Observing effects is just seeing output. That's not a bad thing. But maybe it's something more like limited non-algebraic effects, effects that I can't reason about purely by using algebra and composition. And maybe that's the problematic thing. And in that circumstance, again, flapjacks gives you pretty good algebraic reasoning while still giving you the ability to write effectful programs without having to go into sort of an I/O monad or something like that. I don't know, and I don't really know exactly what this picture should look like, so this is more a spur for conversation than anything else. But before I take questions, I just say that, somebody else has to do all the work, obviously, because I just give talks. So yeah. I write code occasionally, but somebody writes much more code than me, so these are the guys who did it. And in fact, Leo, who's the lead author of Flapjacks, is coming here in 2 weeks to work with Ben this summer. So that's awesome, good choice. Okay, so questions, comments, anything else? You look like you're about to say something about that previous slide.
Yeah, I guess the characterization. Well, so what is your thinking along in terms of the concept of dynamic types? I mean, so you're talking about side effects, right? You're not talking about.
Yes, this is purely about side effects. This is not about types at all. No.
Right, and so a lot of people would say dynamic types are a source of inability to reason and also safety, right? I mean,
yeah.
Basically, so it seems like that's not even in your.
Well, that's not in mine. Partly because I was just quoting Simon, okay. Right? But also, I would claim that static type. I mean, there's difference between types and safety, right? Static types are a syntactic discipline, right? Reynolds always says this. Types are a syntactic discipline that you might run on a program, right? Safety is a concept of whether you have abstraction boundaries in your language and whether the language enforces them. How it enforces them is the responsibility it's some combination of factors. Even in a statically typed language, it's still the case that not all of them obviously can be enforced statically, so that some of them must be enforced dynamically. So in some sense, a scheme programmer is much closer, or at least a good scheme programmer is much closer in mentality to an ML programmer than to a C programmer. Right? Because the scheme programmer still believes that it's good to have abstraction boundaries. It just so happens that they're all enforced completely at runtime, and that can sometimes be problematic. Okay? As opposed to, I don't want abstraction boundaries, or put differently, I have only one type in the universe, and then there's no abstraction boundaries to even speak of. Right? And that type is like the 16-bit word or something like that. Right? In fact, C, I claim, is a very peculiar language. Even the notion of talking about soundness of C, I claim, is a very strange thing to talk about, because normally when you talk about a soundness theorem, you're trying to say that there's some static discipline that's trying to mimic what's happening at runtime. And so I have runtime behavior that corresponds to it, and the soundness theorem is saying that this accurately simulates what's happening at runtime. Okay? But that's not how C works at all, right? C actually has two type systems. It's got a static type system that has things like int and bool and words like that, right? But then in the dynamic type system, all it has is like, 16 bits or 32 bits or 64 bits. And you can't even ask, is this thing one of those things? So the notion of soundness is meaningless because the runtime types and the static types are totally disjointed universes. So you can't even call C is not even unsafe, right? It's something beyond that. I'm sorry?
Beyond unsafe.
Yeah, it's beyond unsafe, right? Beyond mere distinctions of safety and unsafety. So I want to make a distinction between safety and typeness. And the other thing is also there's this worst situation where you have a static type system, but it's not safe. It's not a sound static type system. Which is you run this thing and you think you're getting a guarantee, but you're not, right? And those languages exist too. So I would claim that we really should separate out those concepts a little bit. But I think static typing is a good thing by and large, and well, tomorrow I'll say a little bit about it even. So, yeah.
I want to ask you about, actually it's a related question about safety and sort of foundations and building on top of things. You're building this language programming model on top of a runtime. And you don't really know all that much about that runtime. So
Yeah.
for instance, you're talking about seconds.
Yeah, yeah,
There's
yeah.
nothing approaching even real-time guarantees that you get. from the
Absolutely,
JavaScript runtime.
absolutely.
You don't know much about the ordering. You don't know much about a few other things.
Absolutely,
As well.
absolutely.
So could you, I mean, in this work, did you, I don't know, work out a set of suggestions for a better set of runtime guarantees, perhaps?
Yeah, it's a good question. No, because we're trying to do something sort of dirty here, right?
You have to do something clean.
Well, that's tomorrow's talk,
Okay.
right? I would start with trying to get the static types cleaned up and then go from there, right? Because again, I'd need some, to get guarantees, I want to be able to talk about static and dynamic guarantees as part of a continuum. And so that's why we're doing the type system work, right? So you're right. I mean, even in Father Time, right? Technically, Father Time is built on top of Dr. Scheme, which I should know a lot about. But what is Dr. Scheme? It's like, 700,000 lines of Scheme code, another 100,000 lines of C++ code. So who the hell knows what these things do, right? So in some sense, getting any notion of guarantee out of modern runtime systems seems to be, slightly wishful thinking. I mean, I don't know. There are people in this room who built a pretty amazing runtime system.
Specifications, say the CLR, the Java VM, they at least attempt to implement this specification.
Yeah.
For the JavaScript runtime.
Yeah, that's right. That's even much worse. Yes. Well, it's also which JavaScript runtime, right? Because there's the JavaScript runtime. There's 5 different browsers, and each of them more or less
That's
has.
the question. If you have to define one.
Yeah. I agree. Yeah, it would be nice. I don't know that this work has produced much by way of recommendations, other than, maybe take the Java runtime and translate it or something. Yeah.
So you made a strong case for why it makes sense to start using flapjacks to design pages. But what if I already had a page with tons of JavaScript? How would I?
So that's why we provide it as a library, right? So you can go in and say, I've got this element over here and I want to make it reactive. So I can attach, so the library design is a little careful that way. If you say $B and I attach something to an event stream, it leaves the existing callbacks in place, but adds, the implementation is all by adding callbacks to the existing callbacks, right, by chaining.
But what guarantees do you provide in that case? Because every function may do things that your system can't do.
So Flapjacks was intentionally, unlike Father Time, Flapjacks was intentionally designed to be a compromise, a real-world compromise. Right? So we could say, well, we could reject all programs that are not pure functional with Flapjacks, and I think that would be useless. So what we do provide some ordering guarantees, because if you write something imperative and you launch a bunch of events in an imperative sequence, we provide some ordering guarantees there. So that much we have. But we don't say anything about completely random code that we can't see. And we could, but I know what to say, but we haven't bothered doing it because that would mean doing program analysis of JavaScript. But that doesn't exist till tomorrow afternoon. So, yeah.
So whenever I've seen a talk on so-called visual programming, they tend to, because it's what you can express as a graph, they tend to come to the same sort of programming language, event streams, and
that's right.
Have you thought about, well, since that fits, making a visual?
Yeah. In some sense, that's what Yahoo Pipes is trying to do. Right, Yahoo Pipes is a visual language where you can actually drop events and plug them together, and they've done a lot of work on trying to, parse like the 25,000 different web services out there and so on. It's still a very discrete model. It doesn't have this notion of behaviors. I think we could. Anything we produce would look shabby compared to Yahoo Pipes. We wouldn't be able to compete with them, right? So in some sense, we're like pipes for textual programmers. Yeah.
Well, if I may...
Please. Dive in.
I was going to ask you about Yahoo Pipes as well, but their evaluation model doesn't seem to be nearly as clear as yours.
No. So they don't offer any kind of semantic guarantees with the evaluation model. It's kind of, get what you get. So the behavior is whatever the program does by running. So yes, we could, in principle, maybe steal the Yahoo Pipes UI and put Flapjacks under it, and that might be a much better alternative. Yeah, that's true. Yeah. Other questions? Okay.
So how far is this programming model different from the functional reactive?
Yeah, there's several ways. There's the evaluation model is different. So functional reactive programming that's our underlying inspiration. But for example, there's no FRP work that says here's how you take an OO library or some OO primitives and lift them automatically to a functional world. They haven't even had to think about that, and we provide that as a sort of systematic thing you can do. We also most of the FRP work happened in the context of Haskell, where you kind of get event streams for free, but they don't have to think about what call by value evaluation has to do with this. What we have, I think, is a fairly clever way of embedding the graph construction process as a call-by-value program. So we sort of transform your program into a call-by-value program whose execution automatically builds the graph and then runs the graph for you. So that's sort of that's a pretty big deal, because it means that I can give you the certain guarantees about how this program's execution matches the underlying JavaScript execution model or the underlying scheme execution model, that if I didn't, if I had to write a hand interpreter or something, I wouldn't be able to get those kinds of guarantees. So we're very inspired by it, but I would say we've gone in many different directions from there. Call-by-value evaluation, the push-driven model, the object-oriented connections, the optimizations that we've done. I mean, so part of it is if you do this naively, we had a paper where we showed a speed up by not percentage but by factor of 68. Okay, what that tells you is if you do this naively, it really sucks. So it's pretty easy. When you see a factor of 3, it's like, wow, that could be clever. But if it's factor of 68, you just know the original was really dumb, right? So I can't take too much credit for that. But we've done things like that. So all of those are novelties that the original FRP work didn't have. Yeah, but they did great stuff, and more power to them. Yeah. Yes. Very good. Thank you all for coming. Yeah, and thank you whoever's out there for coming too.